Hi, good day. Thank you for taking the time to view our web demonstration today. My name is Marcus and I'll be the application specialist taking you through the web demo for the Cobalt Array 3D Imager along with the Rotary table which you see placed on our granite table. So before we proceed into the demonstration, I just have a quick PowerPoint presentation to share with you. So our agenda for today's demonstration is to firstly share with you a company overview of Faro, and then we will go into a system review where I'll mention some hardware specs about the Cobalt Imager, and following that we will go into the hands-on inspection itself. And for the hands-on inspection, I will firstly show a automation example with this single unit of Cobalt with the rotary table. And then following that, I will show you step by step how this automation is achieved, or what are the individual steps to achieve the things that you saw in the automation example. So we expect today's demonstration to last about 30 minutes. And we will start off with a history of Faro. So in 1981 was when we started in the medical 3D component industry with articulating arm technology. And following that, in 1994, Faro transitioned into the industrial manufacturing markets. Over the years, they have developed various kinds of solutions such as the arm, the laser tracker, the focus 3D scanner, and even the Cobalt array imager. So to give you an idea of our global footprint, we have our global headquarters located in Lake Mary, Florida in the US. Our European headquarters is located in Germany, and our Asia Pacific headquarters is located here in Singapore. So for the product overview, uh, starting with the Edge Scan Arm HD, we have in this arm a contact as well as non-contact measurement solution for you for part sizes up to about 5 meters in size. Following that, we have the Laser Tracker Vantage S, which lets you perform contact measurements for part sizes up to 80 meters in size. Today we'll be going over the Cobalt Array 3D imager, so I'll provide some details in the later slides. Sorry about that. So for the Laser Projection Tracer M, it is a laser projector that actually provides laser projections onto parts, and this replaces the need for physical templates. So you can use the projector to project drilling points, placement points for welding on your parts during the manufacturing process, as well as for paint and decal templating for planes or for ship house, for example. Then we have the Focus 3DX series laser scanner, which is used mainly for building information modeling, civil information modeling, as well as accident and crime scene scanning. And we have over here the Freestyle 3D scanner, which is a handheld 3D scanner used for mainly product design and reverse engineering. We also offer a software suite for use with our hardware, and our hardware is compatible with third-party software such as Geomagic and Polyworks. So, to share more with you about the Cobalt Array 3D Imager, as I mentioned, it's an automated non-contact coordinate measurement machine. There are two resolutions available for the camera, 5 as well as 9 megapixel, and this would determine the amount of detail in terms of the number of points captured per scan. So for the 5 megapixels, 5 million points, and for the 9 megapixels, 9 million points. They offer interchangeable lens kits with this Cobalt Array imager. So there's the option of the 500 lens, which gives you an accuracy of 50 microns, and the field of view of 500 by 360 by 300 deep. And for the 250 lens, it offers an accuracy of 27 microns and the field of view of 260 by 200 by 90 deep. The technology involved in this projector technology is the DLP, and it emits a blue light via a blue LED light source, which will be reflected and captured by the cameras on the unit, and that is where you will obtain the point cloud scan of your part. In terms of the electronics, there's an embedded computer on this Cobalt imager, so it provides fast, dedicated point cloud processing. And additionally, the presence of the onboard computer enables you to use the Cobalt imager in an array setup. So if the part that you're scanning exceeds the field of view or size of a single unit, you can link multiple units together to create a simultaneous scan of your part. Each unit is lightweight at 5 kilograms and no field calibration is required. So once you have done your first calibration in the office, you can bring it out to site for scanning. Sorry about that. So there are various deployment options for the Cobalt Array 3D Imager. There is the tripod mount, which is useful for reverse engineering applications and non-recurring inspections. You can mount it on a tripod and use it with a rotary table, which is good for inspection or automated inspection of small parts, which we will showcase today. As I mentioned earlier, you can use the Cobalt in a multiple imager array to capture part sizes that exceed the field of view of one unit. And you can also mount the Cobalt on a robot arm in order for fully automated inspection applications. So here's just an overview of the various industries in which the Cobalt Array imager is commonly used. And as you can see, it's used a lot for product development, quality control, as well as reverse engineering for all types of surface finishes, all types of surfaces and part types, as well as large and small parts. So now that I've shared with you a little bit more about the specs as well as applications for the Cobalt, I will proceed into the demonstration right now. Firstly, I'm going to change the camera view to the overhead camera view so that you'll be able to see the Cobalt in operation with the rotary table during the scanning. Okay, so if you look in the software view right now, what happens is that we've already taken a scan of the part and then we've overlaid that over the CAD drawing of the part and we've gotten some deviation markers at this point here. So you can see the deviation points over there. So what I'm going to attempt to do firstly is to show you an automation example. So I've saved this project as an automation example. And if you're an operator and you would like to conduct this automated process, all you need to do is open up this program, move to the automation tab and press play. You can fill in relevant information such as the part name, program name, session name, and operator name. When we click on OK, what will automatically happen in this process is the rotary table will rotate to the 4 positions to perform a scan on the part. But firstly, if you look at the CAD drawing, you see the green dots on my CAD drawing. So those green dots are where deviation points will be taken. So we've gotten the first scan from the first rotation. Now it's going into the second scan. And what you will notice from these 4 scans is that each side or each face of the scan is automatically stitched to the previous face, so you get a nice complete image without having to do additional work. As you can see, there is blue light being projected onto the part, and this light is reflected off the part and captured by both the left and right camera. So the advantage of using blue light is that whether or not it is a light or dark surface, matte or glossy finish surface, you'll be able to scan this part by just setting an exposure setting for the cameras located on the Cobalt. So that's something that I will show you in the second part of this demonstration. But for now, what we would just like to showcase is that automatic inspections can be performed by just creating an automated program and saving it for the operator to open and carry out. So all I've done so far is to place my part on the table and press play in the automation tab. So right now, realigning point cloud is the software is actually aligning the scan, which you will see in gray, over the CAD drawing to obtain the color map. And you can see the deviation markers have been automatically generated as well. And once all this is complete, a report can be automatically generated as well based on all these analysis that I've done. So what you will see in the background screen is that the software is actually updating the report to reflect all the scans and inspections and analyses that we've done so far. And what you'll see in the foreground screen is that the report can be saved as a few formats. There's the CSV format, and we'll just wait for the computer to process this, and you'll be able to see the other formats which the report can be exported in. So there we have PDF, as well as text, as well as HTML. And if we open up and look at the preview report, you'll be able to see the color map laid over our part with all the deviation markers. And if I scroll down, you can see a summary of the point cloud, the number of points captured, the distribution of those points in terms of their tolerance. And over here under points here, what you're actually seeing is the deviation markers found in that point cloud. So there are 4 point clouds combined with deviation markers from each one of them. And you get to see the deviation values from the CAD drawing. And we also get a cross-section scan automatically done. I will show you what or how the cross-section scan is performed later. But just note that this can be programmed in as well. So we've taken a cross-section across our part along this section. If you look at the video feed, we've taken a cross-section across this line here. And this is the shape that we see here, and you get the same summary, and you get you can pinpoint easily which area on your part has points that are under or over tolerance. So that brings me to the end of the first part of our demonstration. And right now, I will show you how this is done in a step-by-step way. So just give me a moment. So we've reopened up the software. And the first process is to ensure that your device is connected to and recognized by the software, so we can see that it is. Next, we just need to go into the Measure tab and select Point Cloud. This prompt asks whether you would like to use the Rotary Table Wizard, which will guide you through using the Rotary Table for your inspection. So if I select yes, a window will pop out. And over here, we are able to choose and select or input how many rotations you would like the table to do, and accordingly, the angle for each rotation will be calculated. There are a few other options there, but we will proceed straight to the meat of the demo. So the first thing to take note of in this row of options is the home position. So if you've done a few scans, you can select this to return the table to the original home position. The next thing you will need to take note of is this range finder. So when I click it, you see that a red box appears both in the left and right camera view. And if I place my part there, the idea is that the cross that appears should appear within the red box on both the left and right camera, and it should be on your part as well. So this tells you that the part is within the correct focal range from the imager. Next would actually be the over and under exposure preview. So this is what I was talking about, whereby it does not matter what kind of finish your part has. The idea is to change the exposure according to the type of finish your part has, so that the color on the screen is a silvery or gray color, because areas in red are overexposed and they will not be captured based on that setting, and neither would areas in blue. So I had previously selected exposure of 84. And we can also change the focal range or focus area within the camera view, and it will change accordingly for both left and right. And once you're ready, all you will need to do is click on scan. The table moves to its first position and the first scan is being carried out. So this is again similar to what you saw in the automation example just now. So again, we'll get the 4-point clouds, and again, those 4-point clouds would be automatically stitched and registered. Okay. So now that we've gotten our 4-point clouds, we can go into fine registration. So this process is cleaning up the scans that we've taken. Once we've done that, there's an option to merge those 4 separate point clouds into a single one as well. So that can be done in this software. And now we have a single point cloud representing our part. And the next step would be to import the CAD drawing for this part so that you can do an alignment and comparison. If I go to the alignments tab, before I proceed with the alignment, you notice that both the CAD drawing and our part are currently not aligned. So if I select align point cloud, it brings me to this page. And just to give you an idea of the process being carried out, the point cloud that we have scanned on the right hand side will be overlaid on the CAD drawing on the left hand side to give you the color map. So this is an automatic process. I click on solve and the software would recognize the shape and do an overlay. And there we have the result over here. So we see the color map across our part, and we can see that it is quite uniform across all corners of the part. So the first thing that we can do, I showed the deviation markers just now. So in order to obtain that, we go to pick, generate. We can select an area to generate deviation markers for. You can increase or decrease the number of points based on the spacing. So there we have the deviation markers as you saw just now. And for cross-section scan, I can construct a cross-section scan by visually dragging a line across my part. So just let me adjust the view, go back into that. This was the area which I created the cross-section scan for just now. So if I create it again, there we have our cross-section scan. If I open up the cross-section analysis, there we have the cross-section here. So I'll just zoom in and show you some interesting features. So over here, the color line depicts the point cloud of the part that we scan. Red or orange indicates over tolerance, and blue or blue indicates under. And the gray outline is actually the CAD drawing. So we get an idea of the profile of the actual scan over the CAD drawing. And we can do some basic analyses, such as we can do a radius check on the points here. We can also indicate the highest and lowest deviation points based on this cross section. So if I zoom out, you'll be able to see where the lowest and highest deviation are on this cross section. And when you are satisfied, you can actually capture multiple screenshots for your report. So before we generate our report, it's important to align the CAD view to what you would like to appear in your report. And once you have done so, you can click on the report button. Again, make sure that you include all the features that we've done so far. So it will be the point cloud and the cross-section scan. So again, the preview would update for you so that you get an idea of what the report will look like. So if I scroll down again, we get the same point cloud here with all the deviation points that I mentioned earlier. And then we have the cross-section scan, the same summary, and the distribution of points across the cross-section, and the two screenshots which we captured. And when you are satisfied, you can export the report in PDF, in CSV, or in text or Excel format. So that brings me to the end of the web demonstration. We've shown an example of an automation project where automated inspection can be carried out by saving a program and inputting the steps that you would like to carry out. And then subsequently, I showed you how those steps were carried out one by one and how essentially the Cobalt imager works. So we hope that this has been an informative session for you, and we thank you once again for your time in viewing our web demonstration. Have a nice day.